In this lab, you're going to be investigating blackbody curves, and this was discussed in the lecture. But a blackbody curve is the amount of light, the intensity of light that comes from an object, and it's compared to the wavelengths of light that come from that object. So every object produces some sort of a blackbody curve. So depending on where the peak of the curve is, the peak of the curve, the wavelength that it corresponds with, tells us about the temperature of the star and the color of the star. So in order to get this blackbody curve, we have to measure different wavelengths of light that come from a star. So for example, if we have sunlight that travels through a prism, the different colors of light are going to refract or bend differently, different angles, so it spreads out the different wavelengths of light, so we can measure how much of each wavelength come from that object. Then we make a graph and plot it intensity versus wavelength. And in the blackbody curves you're going to be investigating, a lot of them are going to peak in visible wavelengths of light, but some of them will peak more blue than violet, shorter wavelengths than violet, and that range, again, is called ultraviolet. And we also look at objects that are giving off light, giving off a blackbody curve that peak in longer wavelengths than red. And we call those wavelengths infrared, so kind of past red. Before violet is ultraviolet, past red is infrared. So here in this example from the lecture, we have 3 stars, A, B, and C. They're all the same size, but they have different temperatures. So star A is 12,000 degrees Kelvin. B is 6,000 Kelvin, and C is 3,000 Kelvin. And so what we notice is that their blackbody curves are different in a couple of ways. One way is that star A, the hottest star, has the tallest graph. So we learned from lecture that luminosity or intensity of light depends on the size of the star and the temperature. So hotter stars give off more energy. So the hottest star is going to have the tallest peak on the graph. The coolest star has the shortest graph, the least amount of energy coming from that star. Another thing that we want to pay attention to is what color or what wavelength each of these blackbody curves is peaking in. So with star A, the hot star, its peak, it's not even peaking in visible wavelengths, so it's before violet, so it's peaking in ultraviolet wavelengths. Star B is peaking in greenish wavelengths, and star C is peaking, it's not even peaking in red wavelengths, it's after red, so it's an infrared. So star A is going to be the bluest star, star C is going to be the reddest star. So in the simulation you're going to be working with, you're going to investigate how temperature affects where the peak is and the height of the curve. So when you go to the simulation, when you go to the website, you're going to click Run Now. If you get any errors, if it says to activate Flash, just click where it says Activate Flash. If it's something else that's happening, go to the browser checker on Blackboard in the the lecture course website, and just see if there's a plugin that you need. So once you get the Java simulation running, it'll look something like this when you first open it up. So on the left-hand side, you have a blackbody curve. So you have intensity versus wavelength. It's going from bluish wavelengths on the left, reddish wavelengths on the right. And on the right-hand side, there's an indication of temperature, and the temperature is in Kelvin. So you can either type in a temperature, type in a number, or you can use the slider to increase or decrease the temperature. And to the right of that is a thermometer that gives you the temperature or relative temperatures of different objects: the sun, a light bulb, an oven, and the earth. On top here is an indication of what that object would look like. So for this blackbody curve, you have kind of equal amounts of blue, green, and red coming to from that object. So when we look at that object, all those colors come together and we see something that looks kind of whitish. And you'll see as you change the blackbody curve, the color of the object will change. You may find that your blackbody curve is either really small, short, or really tall, and you can't see it all. So you may have to adjust the view of your blackbody curve by either zooming in or out, the intensity or the wavelength. So whatever the situation, you want to be able to see the peak of the curve, and you want to see either side of the curve in the simulation to answer the questions.